Hey guys, and welcome back to the channel. I have two MEFI 3 computers coming from New Jersey. Bill, these are your computers. Their concern is, actually, let me read it from the text message he just sent me. It says, intermittent stalling when coming off plane, surging at low speed on both motors. These are twin motors, 7.4 liters Volvo Pentas. And I have all the information ready to go. So let me move over to the next capture. So I have module 2, which I have marked 1 as 1 and 2 as 2. You'll see it on the pictures. Well, actually, I don't think I have it on the picture, but this one is the one ends in 36. The other one, marked as 1, is the one ends at 72. And you'll see those numbers in a second. All right, let me take you over to the folder. All right, this is a picture I took of both modules before starting the test. And I didn't I didn't put the mark before, but I have now marked this one as 1 and the other one as 2. The one with 36 is number 2 and the one with 72 is number 1. So the last digits are the ones I'm talking about. You see it says 9372. So 72 is number 1 and then this 36 is number 2. All right, so I have created a folder for each. Oh yeah, I have it in the folder and I have capture or recording of each module, and I also took a snap pictures of different RPMs to compare one module to the other. This is the capture before running it, and no full codes to go by. This module had on history 676.4 hours, and I can see that this clock right here at the bottom, let me make that a little bigger. Yeah, you can probably see that in there. So this module, the clock is counting hours per minute. So it's changing the hours very, very fast. The running time is running normally. It's like 10 minutes, 15 minutes or so, but the hours are changing rapidly, but nothing affecting the running. So right now I have module 2 connected. So let me make sure, or let's go over the diagram and the oscilloscope. So I have the oscilloscope. The blue channel is connected to injector bank A, and the red channel injector bank B, and the green channel is the coil firing for the A cylinders. This is the distributor, so we will have a one coil firing in the distributor, and then the distributor will send those spark to each cylinder as the rotor moves, right? So right now, this one, let me just show you that, it's been running for 16.58 minutes. He said that this happens mostly after it gets hot. So I've been running this one, module 2, for a longer time than number 1 to see, because since it's the same thing in both, I'm trying to see if it's something changed. So let's gather the capture on number 2. Let me see if I am in number 2. This is module 1. So yeah, module 1 is the one we're going to compare the values. So right now I'm in 4,000 RPMs. And I'm going to move these to the bottom so we can see that, injection and everything looks pretty much the same across the board. I'm going to select different bits so we can compare. Let's say, the RPM is a little lower. We have 472 or 70. It's like 9 RPMs lower, but that's pretty much the same. I'm going to actually move it here. And then things that are important, the injection milliseconds, 6.1 milliseconds. And we can see that in here being the same, 6.1 milliseconds. So what is that thing showing in there? So weird. Let me see, what is that image showing on the left side? Not sure what that is. Let me get to that image. 1 second, guys, to fix that. It was just the image overlapping over to the other screen that I have, the iPad, so I can see what you guys are seeing. But yeah, so we got the same injection. Let's take a look at the throttle position and percentage. It's pretty much the same. I'm in 39.1 on the, on the capture on number 1. The voltage, sorry, not that one. The voltage on the throttle position sensor, 1.8. The other one is in 1.82. So we can see that little difference on throttle is okay. So we're very close to each other. The eye position in 133 in number 1, and this one is in 113. And that all depends on the throttle position. Because if I move that just slightly, you're going to see how that changes. Let me see if I can do that. And that all depends on how much I'm coming down. But yeah, we have a little bit of a difference on the IAC on this capture. So let's see. That's the only thing that I can see difference, the IAC position. But again, that all depends on the calibration of each module. And the thing that I'm not changing is the manifold pressure. It's in 16.34 or 16.4, and it's the same on the other one. So we are matching that pretty much to the dot. So let's come down to 3000. I'm going to select in here the 3000 RPMs capture that I have from number one. Again, we're going to compare tomatoes with tomatoes, right? All right, so let's come down to those same values. I'm going to come down to 3072 as close as I can, right? Because it's a little sometimes, especially with this knob in here on this auto simulator, it's sometimes a little hard to match perfectly an RPM. So I'm trying to go very soft. It's very hard. Yeah, it goes from, let me see if I can go up the other way and I might do something different. Let's see. Yeah, that's still not perfect, but it's very close. So yeah, that's the difference that I have in here. So I need to bring the throttle at 29.7%. 29.7. So around there. All right, let's compare the values. We're going to do the same thing. So the RPMs, we can see there we're matching. I'm not changing the manifold pressure, so that's not going to change. That's going to be across the board the same. Spark Advance 30.1, we have the same on the right side picture. 29.7 is matching pretty much perfectly. The throttle position voltage 1.53, and the other one was 1.55. Again, that's not going to change. We stay on the 113 IAC position, so it looks like this module calibration is put in that one, and they both have the same calibration, F9FA, which is right here at the top. Things that I want to show is, let me see how many hours do we have in the history. Let me see. Not this one. Let me go back to see how many hours we have on module number 2. 388. 388. Let's see how much we have now. 410. Yeah, so these clocks are not reading properly, neither one. Because I have run this, and we can see here, I have run this for 22 minutes. So 22 minutes, and it's already showing 410 hours. So it's counting minutes per hour. So this clock, and again, it's just an hour clock, is going to be changing very, very rapidly. And we can see that, from 20 minutes of running time, we have already 20 hours gain on the clock, on the engine hours. But the running time is correct. You see 22.98, 23 minutes, and it says minutes, not hours, which is correct. I haven't run this for 20 hours, right? All right, so but yeah, that's the only thing I can see in their difference. So the Spark Advance, everything is pretty much the same. The flow rate of the fuel is a little different, and that is again calibration. There's nothing I can do with that. But there is no fault codes. I want to show you that. There is 0 trouble codes. And again, this has been running for almost 25 minutes. All right, so let's pick up on 2000 RPM from this capture. Again, to compare those values and see if we see anything that is up, because it's being very difficult. They don't have fault codes. They have just a concern, a symptom, and they were trying to, to correct. And this is a rush test. All right, so let's go down to 2098. I'm going to go slow to see if I can match those. Okay, so that's as close as I can be. And let's put the throttle at 19.5%. Away. Around there. So that is pretty close. All right, so we have again the throttle at 19.5%. Up and down a little bit is normal on these computers. The voltage 122, 124, and this we have the same thing on the capture that I got from number one. The IAC looks like it's not changing. Again, this is calibration, and we can see how in the other one it's staying so far in 133. So that is not changing. And the 7.4 liter usually is changes only when you're an idle. It doesn't change or otherwise. So spark advance 28.4. We got the same thing. And injection millisecond 5.2. The other one 5.3. So they're pretty much an image. Temperatures are exactly the same from one to the other one, and the manifold pressure. I'm not changing nothing on those. All right, so let's select the 650 RPMs. And you can see how I run the other one for like 10 minutes. It's not that I didn't run it long. I just, wanted to try number two to see what we can see. Now let me get down to idle. And I don't see any glitches on the injectors or coil or anything that will make the engine stall like what he's describing. I'm trying to go to 652, so we're pretty close in there. 0.8 throttle position. And this is where we will see the IAC changing completely. All right. So, and it's matching, right? So this is where I'm saying that, the IAC, whatever they open after idle, and this one is not really match of it's just whatever the manufacturer puts on that calibration. But we got the 0.8 voltage wise, 0.67. We have, 0.69 on the other one. So that's pretty close. Spark advance minus 11.9 is the same thing on the other one. 3.6 milliseconds of injection. We got exactly the same thing. And now the IAC. The IAC is base IAC position 83, desired IAC position 83. So we are matching both in those captures. So I'm not sure what exactly is his concern. The problem, but I cannot reproduce that here. So we right now have been running these tests on module number 2 for 27, almost 28 minutes, and it has not a stall or give me any hiccups in here. So as we can see, is not really anything different. So I'm going to upload this picture as well so we can see that. I'm going to increase the RPMs again. I'm going to go over to 4,000 one more time. I'm going to change the RPM first, and then I change the throttle last. Around there, and then 40% around. I remember it was like 30.95 or something like that, right? I'm going to leave it in there. All right, so yeah, nothing. You can see the injection is pretty clean. So is the coil firing. Nothing is glitching whatsoever. And things that we need to see in here is like right here we have the IAC position at 133, but look what the computer is desired. So this is where you will match. And I'm going to connect the number one module to run a little. I'll do a run in the video for Bill and you guys to see. This is the test that I always do. Very important that I can also say, when you are having problems in a boat, your best tool, your best help could be is diagnostics in an oscilloscope. Because with the diagnostics, you can see the values, what the computer is, kind of like, requesting and inputting and outputting. As input from the sensors and outputs to the coils and injectors and the IAC valve in this case. But without the oscilloscope, you don't know if that in reality is happening. So I can go over to the scope and I can, let me change the time base a little bit. I'm going to put cursors in here to measure the injection time. is going to be the bottom part. That's the opening of the injector. And it's showing 6.4 milliseconds, and we are seeing in here that the computer is commanding 6.1. So that is correct. So this is how you test. Okay, well, the computer is commanding 6.1, but you're going to see 20 milliseconds. I'm like, oh, what's going on? Right? So this is definitely not right. And then you can also check things like, like manifold air pressure, which is one of the main inputs in here. Temperature is also too, but you have the manifold air pressure, and you're going to say, well, I cannot convert that. Well, you have also a manifold sensor voltage. You can do that, and then, okay, well, the computer is seeing 2.39 milliseconds, 2.39 volts. And then you go over to the signal on the sensor, connect your oscilloscope, and then read that value. If it's different, well, the sensor is reporting 2.4, but the computer is seeing 5. Why? This is it a short in the voltage? On the signal wire, or we have a problem in there. So you can see what the computer is seeing, and then also in reality what the sensor is reporting. And this is where the oscilloscope is your best help. The reason I don't recommend to use a multimeter, which is also a good tool, is that you can only see an average. In the oscilloscope, you can see the waveform. That up and down is called waveform. Why? Because it's changing on time, right? So we can definitely see the injection millisecond, the coil firing, everything. So that is why the oscilloscope is so handy. But again, build, assist, there is absolutely nothing wrong in neither of these two computers. I don't see nothing wrong. I'm going to come down to idle and see if we lose. Let me change the capture. Let me take those lines out of the oscilloscope. I'm going to change this to a 50 millisecond capture. All that changes is how much time per screen I get on the oscilloscope. All right, let me go down to idle and see if we lose anything. For an engine to stall, we have to lose injection of coil, right? Because it's the only thing that keeps the engine running, right? The fuel and the spark. Let me go down to around 0.8. Went too far down. It's a little hard with these little knobs to do that. Okay, we're around there. Right, we have coils, we have injectors, and now the injection millisecond is calling for 3.6 milliseconds. If I do the same thing and I put, the cursors, I might need to, no, I can do it in here. So this is going to be a little close. So we got like 3.9, the computer is calling for 3.6, so it is matching, right? So we are looking at the results of what the computer is commanding and what the injectors are firing in reality. But again, I don't see nothing wrong. This time the IF position went down to 103. And this is whatever the computer calibration commands. Let me change this throttle. So yeah, this time is in. Let's change that. Because I'm seeing just a little thing in here now. The throttle position is in 0.59 voltage to go to 0.8. If we go back to the capture, let me get the capture at idle. We got 0.69, so we lost 100 of a volt on the throttle position. And let's raise that up to 0.69 to see what 0.69 is now. Yeah, 0.69 is 4%. Okay, we might be seeing the problem now. This is a problem. This should have not changed, and it happened after 35 minutes. Because we just saw, I'm glad that this is where data analysis is so important, right? So I can compare, immediate recordings of what was fine, and the note that he gave me, Bill, was says it happens only after it gets hot. It was a key on this puzzle to help him because we can definitely see changes, right? So, well, the voltage on the throttle position. Right now we got the same 0.69. So let me just show you that. Come on. 0.69, which matches right here. You see throttle position sensor voltage. It was 0.69 to get to 0.8, but now we're getting 4%. And that is also changing how much the IAC is open, which is going to control the idle, right? So if the computer, because in here I can go down to 0.8, in the boat, he's just got a lever, so he cannot go down more than that. So now the position of that throttle at 0.69 is at 4%. Before it was at 0%. So the IAC is now staying open further. Why? Because the things that you are 4% throttle, not 0%. And that's going to allow air to enter when it's not supposed to, and it's going to make that idle change. And this is definitely going to have, problems across the entire region. And in here, maybe I don't get the engine is stolen because the mixture is not a factor in here. I'm not having, a fuel keeping an engine running. So this is where it's important to understand the test that I'm doing compared to a real engine running, right? But we can definitely see issues in here. Let's do once again. I'm going to go up to 4,000 because I have seen this in the past happening, and realistically, it was not even possible to fix, not even with a calibration. It was something internally in the microprocessor. It was not corrected by anything because this is like the calibration is corrupted, even though we have no full codes for that, right? Because if the calibration will be corrupted, we should get code 51. So I'm going to go over to 39.5, and I'm going to get that picture in a second to us. All right, so let's get the 4,000 RPM from module 1. Yeah, 4,000 RPM. Let's see what we got now. You see, this is where things are different because if I go over to this voltage, is right now in 39.5 or so, 39.1. So pretty much what we had before is 100 of a volt less. If I go over to the same 1.82 volts as in the picture, 18.2 volts, let me see. I'm going to try to match it. Come on. Right there. We are in 42% throttle. And we can see, right? So 42% throttle. Look at the IAC. It's now 150. Before it was 133. So this is exactly where we're having an issue. And this is where the throttle is. The throttle is a main input for the IAC valve, the idle air control. And this is changing. This is changing and it's problematic. I have seen boats or computers, sorry, that changes again when you go up. Like I'm going to go up even farther to maximum acceleration. Let's say, like 90, I think it's 96.6. I want to see what the maximum voltage changes is. See, the maximum I can change the voltage. So, yeah, 99.6 is the maximum, and we have 3.5 volts. So I'm going to take a snap picture of this, guys, to compare to the cold one, right? So let me save this one. All right, so I'm going to, I'd like to reselect this because it's capturing my other screen. Okay, apply, and we're going to save that in number 2. Yeah, number 2, 4K RPMs, 99.6 TPS, hot. All right, so we save this one. Before I connect the other one, let's go down to idle to see what is now the reading on idle to get to that value. All right, I'm going to go into voltage. I'm going to not use the percentage. All right, so we're around idle value, and I'm going to, what was 0.69? Pretty sure it was 0.69, but let's get that picture. Module 1, 650 RPMs. Yeah, 0.69. So we're almost, yeah, not almost. We're in 4.3 now at that voltage. And the IAC position is in 133. So this is definitely problematic. I'm going to save that one as well. So let me save that. I'm going to change this to save it to rectangle, like that I can select what I have in the screen. All right, let me save that. And this is going to be 650 RPMs, TPS, 0.69 volts, hot. All right, so let me stop this, connect the other module, and I'll be right back, guys. I got module 1 connected. Let's power it up. And so the reason I put you into this view so you will be able to see the fuel pump coming on. All right, we got fuel pump prime, we got sensor ground, 5-volt reference, and we have IAC. And I saw the ASC relay too. All right, so let's get into this view. Let's connect and look at the hours, right? So we got 429 on that one at the end. Sorry, I'm busy. Leave a message. All right, let's connect. This one now has 687 hours. All right, let's run this one in idle. And right now we're seeing the IAC in a very slow position. That's just very normal when you start from cold. So we can disregard this one. I'm going to go over to 4,000 RPM. Let me run the oscilloscope. I'm going to go over to 4,000 RPMs. The IAC will change when we touch the throttle. So 4,072 around there. And I'm going to go to the 39.5. All right, so very close. So we are right now 39.15 or so. The voltage is, the IF position is normal 113 as we had before, and the throttle percentage voltage is 184. So this is matching what we had before. Before this one get warmed, I'm going to go over to the maximum to get a capture of this one cold. So I'm going to go over to 99.6, which is the maximum reading. Yeah, I don't care how much I change the voltage on the throttle or percentage. And let me just show you that. See, this is the voltage on the sensor, and the throttle position is maxed out at 99.6. I can change the voltage. You see, I can keep increasing, but the percentage doesn't change. So I'm going to go down to see what is the 99.6. Okay, that changed. So 99.6 is around 3.65. Yeah, 3.65. So I'm going to take a picture of this. We're going to save it into module 1. All right, so this is 4K, RPMs, cold, TPS, 99.6, 3.65 volts. All right, so let's bring it down now to idle because I want to see that idle 6.9, 0.69, sorry. The stain now should be still very, very cold for the thing to happen, and see if it happens in both modules. All right, let's just go down to the 0.9 volts. Yeah, you see 0.69 is a steel 0.8. All right, so I'm going to say that. This is, again, guys, gathering data. Sorry, it's like a frozen screen because I'm taking a picture. Let's see, module 1. Now this is module 2. Let me save it into module 1. 50 RPMs, 0.69 volts, 0.68 TPS. Cool. Right now you're back in business with me. All right, so yeah, this is definitely intriguing. Let me answer this phone. No matter what, we need to let this module warm up. So I'll be right back, guys. All right, guys. Yeah, I've been running it. It looks like this one is taking a little longer. Well, since I'm here, this is my website. If you are sending a module, all you really need to do is just get to the homepage, which is this one, and then right in the center where you see those big letters, Mike Salazar Diagnostics, just click on the white box that says "Click here to fill this form." That will download a Word document. Just fill all the information in there. The concerns are very important. As much as information you can add in there. If you need to write on the back of the note, that's fine. And then make sure that you sign it. And then just add that note in the box with the module or modules cluster, whatever you're sending, and then send it to me. You please contact me first, either call me or email me. I'm always faster on emails because sometimes I'm in the middle of a work and a call. I will have to, answer and stop what I'm doing. But in an email, I can just read it in the meantime I'm doing this. All right. So let's go back to the test. So as you can see, this one is still showing the same voltage on the throttle position. We got 0.8, 0.4 with a 6.9, 0.69 volts. So that has not changed, and the IX position is staying the same. So this computer has been running for 23.4 minutes. I did open, and let me show you that. I have module 2 open, and I was looking at it. It looks pristine. I don't see any damage on the ground traces or any of the components. So this could potentially be just a problem of a voltage spike that got hit into the microprocessor, and this is something I cannot correct. I did change the calibration on this one, so I have another calibration for the same F9 FA. And I already installed into that one to see if that makes any difference. But this one so far, number 1, is working good. So I'm going to just cover this up to put it here. In the meantime, we're doing this test. Let's go back to the screen. All right, so let's bring the RPMs to 4,000. I'll put these ones in here. Engine running time is not important. I'm going to put that one here, and then the throttle percentage, which are the ones I'm going to be changing in the IX, right? IX position. So we can see that from the distance better. So I'm going to go over to 4,072, right? Like pretty much. And this is, I am trying always to be very methodical as far as the numbers that I use for my tests. Because if I copy that information, or use that same information for over and over, your brain is like a muscle memory. All right, so let's go down or up to, let's go to 40%, 39.5, right? 39.5, around, come on, right there. We're still reading the same 39.5, 1.84. I can remember that being the same. So this one is not reacting as we saw on number 2. Now my question will be, is he has only one engine that is doing the problem, and then since it's a twin engine boat, maybe the other one is the one is doing that and they feel everything. But talking to Bill, he told me that both engines were doing that. Let me actually text him and see if it is. Just make sure that I'm saying this correctly. I asked Bill if this is a twin engine setup. Because if it is, and the reason I'm saying that, if it is, he might be, or we might experience something like, that hesitation, and it's only one engine doing it, and that will make the other one feel like it's happening, when in reality, it's only one happening. I'm not sure if he has turned one engine off and tried to just run the one and then run the other one. I mean, again, I don't have all that information. All I have is the concern in a very short way. Again, remember, guys, this is what I like to show you, how important is all the information you gather. You see how many pictures and different captures and running time to do an analysis, because otherwise I would have say, okay, this is perfect. There's nothing wrong with it. But we notice the change on module number 2. I have not seen that on module number 1. So as far as 27 minutes of running time, this module so far is working good. It has not changed the values to abruptly like number 2 module. I'm going to raise the throttle position to the maximum, 99.6. And we can see which is still at 3.65. You see, if I am in 367, at 363 changes, 365 is the maximum. So that is still matching the same values. Let me go down to 39.5. It's very hard to perfectly do that. So you can see, so these knobs are not really helpful to match that, but we are still reading pretty close. So 1.82, 1.84, and I'm in 38. So it's there. It has not changed. We have 28.8 minutes. Let me go over to the folder to see how long it was when this first one glitched out. Right here. Number 2, 4,000 hot. 38 minutes. Okay, so we still might need a little more time. You see, guys, right here, 38.88 minutes. And that's when it glitched out. And then when you see 99.6 at 3.55 volts. So we lost actually, 100 of a volt, which is changing the IA, because look at the IA position in that one, 150. All right, so and I say the calibration for number 2 in case no change. Actually, realistically, it makes no difference to put it or not. If we see that the hours, because look at the hours on this engine right now, It's up to 717 hours, which at the beginning when this came here, this one had, let me just go back to number one. This one had 676. So we have gained 24, let's say, almost 40 hours. You see, this is definitely not right. But I have seen computers where that does not affect the running or anything. It's just something internally, definitely in the microprocessor. And this is where you see if this would be just the throttle position signal, well, then I will go there to try to see if I can run a wire to bypass. But this microprocessor is, it's a crystal component. So very minimum things you can do in signals. Yeah, there is circuitry in between, which I already checked, and all the resistances and everything is fine behind the scenes. But when you see the engine hours counting like this, that's not a sensor. That's a time. It's a clock in the maps in the computer, and that could potentially be because it's an internal either short or loose path that is arcing inside and is making the voltage glitch, that little voltage glitch that we see on the RPMs in there, here and there, making that think that is a faster clock. You see what I mean? And that is something we cannot fix because this microprocessor cannot be removed, cannot be replaced. There's no parts to change it, at least not for us. Maybe Delphi, which is the manufacturer of this computer, they can do it, but not us. All right, we have 31 minutes. I'm going to go down to idle. Sometimes it needs to change the idle RPMs for the problem to happen. I don't like that 6.6. Any other number? Good. Perfect. 6 or 7. Let's go down to 0.69, right? Well, we're seeing already the problem. You see, I'm glad I went down to idle. Look, 0.69 is already 3.1%. So it has already changed. You see, I'm glad I went down to that because we are already experiencing the same situation. In order to go to the 0.8, you see I'm in 0.8. It's not a huge amount, but we're in in 0.61. So it's almost already 100 of a volt difference. And look at the IX position. I can go back, and this is again where capturing data is the best help you can, because otherwise, by memory, you will not remember that. And I put those notes in there. 650 RPM, 0.69 volts is 0.8% throttle. And I'm going to put that picture here. Let me bring this down. Where you will be, well, actually, I took a picture with the captures, and there you see 0.4%. It was 0.69. Right now, that 0.4% is 0.61 volts. So we're almost 100 of a volt difference. And that is, it is already happening, guys. Definitely no doubt. We are definitely experiencing the same issue. And this I have seen many times. So yeah, it's around 30 minutes of running time. So let me increase the RPMs. But yeah, we have problems with both engines, computers. No doubt about it. I'm sorry, Bill, but this is not looking good. Definitely not looking good. I'm going to try to help you as much as I can, and that's what I'm putting, that calibration onto the other one to see if we have any difference. Let me go up to, I'm going to go over to the 99.6% to see what the voltage is now. You see, we are already in a difference. See, like 99.6%, 3.57 volts. I go over to the folder right here, called this computer. Make this image a little smaller. We don't need that so big. We have 3.65. So it is about 0.8, so 80 tenths of a volt already happening. And this is definitely an issue. and we can see the IAC too, because look at before the IAC at that RPM was in 113 steps. Right now it's in 150. That is your problem, Bill, 100%. So no doubt about it. These computers, both of them, are the issue, and this is definitely the problem. So let me go down to idle. Let me turn all this information off. We don't need it. I honestly don't need the picoscope for this because there's no glitch on either one of those signals, right? So now we know the problem, right? So let me just get this to idle. I always like to bring the computer down to idle before I shut it off. Like now when I started the other one also, all the values are for idle. Yeah, that's around there. And let me bring the throttle. Let me put that percentage in voltage so you can see this too as well. Well, the IAC too. It doesn't matter, right? All right, so let's bring the throttle to. I'm going to keep it in the voltage at 0.69. You see 0.69 is now 3%. And look at the IAC position, right? So it's not changing because why? The thing is the computer is not in idle. And this is where the main problem is. The IAC, the throttle voltage, like we can disregard, right? So I mean, who cares if we have 3% or 2%, but the computer does. When the computer sees 3%, now the IAC is in 150 steps. So it's open when it's supposed to be in in 88 steps. We saw that before, or 113. I mean, I can go back into what we just saw before. I'm just giving you what I can remember, but this is the big difference, right? Because the IAC is now further in, allowing more air, and that's going to make that struggling on the engine as you decelerate, and I can stall the engine and also give that throttle or fluctuation when you are. And yes, I just got a response from Bill that yes, there are twin engines. The surging at lowest speed, right? So that is a very good term, Bill, that you use in there. So let's connect the other module now that we changed the calibration. All right, so I'm going to turn the RPMs off. Let me move you to here so you can see me doing that. And I'm going to put the diagram in the screen so you can see that in maybe a couple of the up now that I move the fit so you can see at least that. So, but since I'm going to turn it off, it's going to erase all that. So, but ignition off, and you always want to wait a couple of seconds before you disconnect the battery. Like in this case, in the boat, ignition off. That's it. You don't need to worry about anything. But if you're going to unplug the battery, you want to make sure the ignition is off for at least a couple of minutes. Let me disconnect from Diacom. All right, so let me turn this computer off. I'm going to keep it where you can see it. Wanted to close so where I can short anything. Let me just take this cover out. Number one is off. All right, number two. Is now connected. Let's power it on. Yeah, let me power it on. Make sure that we get the fuel prime. So let me close all this because that is going to be helpful now. So we're going to reselect and connect the computer. As you're seeing that, all right. So we got that. It will detect the computer perfectly. Mode 1, that's what I use, and then standard diagnostic data, and we connect. All right. So let me just show you this calibration has 652.5 hours. The rest, let's see while we're reading. Yeah, we are in 0.71, but that's not running, right? And it's reading 0%. Let me actually move you over to the display, right? So it's better like that. We're seeing, or you're seeing everything with a better view. So I'm going to select all the data as I had before. So we got the throttle voltage. Let's select the throttle percentage. We're going to get the IAC position. Let's get the engine hours as well. I think that's it, right? Oh, let's get the RPM so you can see from the distance what the RPM is as we're doing the test. All right, so I got everything the same way. That 0.7 is matching what we had before. So let's run it because it will drop down to 6.9 or 0.69, and we can see the voltage is matching, right? So we got that. Again, disregard the IX position now because I need to accelerate it to maximum then for the IX to move. When you start first, it will be in base position, and that is completely normal. I'm going to put the desired IX next to the position so we can see that this is exactly what the computer is commanding because it's seeing that you just started. Yeah, the rest we can really care less. So let's go up to 4,000 RPMs. This office is a little on the cold side, so I might gonna have to run this for a while before we can see it glitching or not. If it doesn't glitch or if it does, I'm trying to get to that close to the 4,072 RPMs we had before. I think that's all I can do. All right, let me get to the 39.5. And we got the same 8.84 or so. Now let me put the running time. Because I honestly think this is actually working better. Look at the engine hours, guys. 652.52. Let's see what changed when we get the next minute. And remember, that is 0.8, so it's a minute is 0.6. So, but we got 652.53. It's not changing hours as the auto calibration was doing it, which it was doing it very abruptly. This is doing it minutes per minute, which is great. Because if I can correct this situation with the calibration, then we have just bad calibration. That would be awesome because then I can help Bill fix both of his computers and he can get these boats back in the water because this is a working boat. He is in a rush. He was actually going to send one of his guys from New Jersey to drop the computers to me. I said, like, Bill, that's just like it's like 5.5 hours just one way. It's going to be 11 hours for your guy. Overnight them, if it was a still time, this was before noon yesterday. He said, just go over to, well, it's 4th of July. You think you can do it? I'm like, of course. It's just Friday. It was Thursday to Friday. And 4th of July is tomorrow. I'm like, okay, so let's just get it done. And I got the modules right here in my door before 9 a.m. See, 3 minutes. We still got 652 hours. It's still early. Let's let this computer warm up. And we can see the IX position in 113.0. But module 2 it looks like it's working. So let's cross our fingers, guy. We can help Bill and make this happen. I'm very happy. It's like I'm a business, but I love what I do and I love to help people. When I can make something and show you all the importance of information and what could potentially be the case, because this can be applied across the board to any computer, any boat, any automotive. Compare the data, cold, warm, SATA data, so you can see it. Because having that picture that I show you and compare it to the values, we all pick it up, right? We all pick it up. And I was about to say, like, yeah, it's nothing wrong, but no, it was. It took a while, and I'm glad that I run both. And probably it's going to be a longer video, but I think it's very important to see this kind of stuff. All right, guys, I'm going to let this run for 30 minutes. We're going to do this acceleration. Keep an eye on the hours, 6:52. I'll be right back. All right, guys, trying to save time. I'm actually did the same thing on the other module. I opened it up and I put the correct or good calibration that I now know is working fine so far. 17 minutes on the module 2. I have module 1 open. Let me just show you here. This is module 1, and the one we have run or we're running is module 2. So both now have the same good calibration that I'm using on module 2 so far. I want to show you, just give you an update. So this has been running for almost 18 minutes. Look at the engine hours, 652.78. So the clock is now reading properly. And that's a very good hint that we might have corrected the situation with just a good calibration. Yeah, this is not just an easy task because we needed to test both modules, run it for that amount of time to make sure they're good. So because this is still early to say, I still want to run all the way up to 30 minutes or so, and then do the drop of the RPM down to that 0.04, 0.08, and see how is that. But let's since we're here, let's let's try to go down, or not down. Let's go up to the 99.6. And we got the 3.65 exactly. So this is matching cold temperatures readings, right? So everything is so far looking good in here. Let me go back to close to what we are, or we were, and let me bring it down to idle. The I guess is staying very good. So I'm going to 647 RPMs. But remember, sometimes the glitch needs to be down in order to happen. So I'm going to go down to the 0.8. And we're still very good. You see 0.4, 0.4, 0.48 is still 0.69 volts. So this, guys, is perfect. Look at the IAC, 83 steps. So this is awesome because now we're matching the values of the cold engine or the cold module, not engine, right? The cold module is still after 20 minutes. So this is looking really good, guys. And this is where data analysis brought me to the correct test. And like I said, if I would have had the throttle position, giving one thing, I said, okay, that's got to be specific to that circuit. But having that clock changing so weird, I'm like, yeah, so this is definitely looking like a corrupt calibration. But look at this, not even a code 51. This is where all modules, memories, and self-diagnostics sometimes are not bulletproof, right? Because this is old technology, right? But again, it's still too soon, but let's keep praying that this is good so we can help this customer. Let me go back to 4,000 RPMs. I want to stress, because the higher RPMs, the more we put the stress to all the circuits due to firing more injectors in the coils, faster. I'm going to try to keep it around there. And let's go down, or not down, up to 39.5. Perfect, 1.84. So we are there. All right, guys, let's run this for another 10 minutes and I'll be right back. All right, guys, 34 minutes. I think this is enough of a test or time for these to fail. Remember, we have it on 27 minutes or so failing. And look at the time, 653 hours, 0.07 after 34 minutes. That is perfect. It's exactly matching what it should have read, not changing minutes or 4 hours as the order calibration was doing. All right, so let's increase the throttle to the maximum, just voltage wise, to see if we got the 99.6. It's still the same 365. And we are there, you see? Look at 365 is 99.6. So we're perfectly matching that. Let me just drop this down quickly to somewhere. And let's go down to idle to see what is the idle reading. After 35 minutes of running time on module 2, around there, let's get down to the 0.8, 0.4. Perfect. Look at that, guys. It's perfect. This is good. This is exactly what we want. 0.4 is 0.69 of a volt. So we are perfect. Everything is matching. Nothing has changed. The hours are good. This module number 2 is fixed. This corrected the issue. So I'm going to, with you guys here, I'm going to turn this computer off. So let me put the diagram in the screen so you can see that when it's happening. All right, so I'm going to turn first the RPM. All right, so we are now going to turn the ignition off. You can see all the computer going to sleep. Now that I see that the IAC and the 5 volts went down, the computer is sleeping now, I can turn the battery off completely, safely. All right, so we're going to disconnect module 2. I'm going to put the cover on it just so for the meantime, we keep that module here. I'm going to keep it on the view as in there. And we're going to connect module 1. Again, we have the cover from module 1 here. I'm going to put them right next to it. And we're going to do the same thing. So let's power up first, right? So battery, ignition in 1, 2, 3. We got the fuel pump prime. That's a good sign that the calibration was accepted properly. I'm going to move you over to the main view. So let me get the diagram out of here. And we're going to move everything here. So I'm going to reconnect like we did with the other one. Mode 1, standard diagnostics, and then connect. So we have, as you can see, 652.5 hours. That is the same hours when we install it onto the other module, right? Right? Because this is the calibration hours. So I'm going to select the same thing we have. So I'm going to keep the hours. I'm going to make it right there. Yeah. So the running time right next to it. I'm going to try to keep those in order next to each other. Throttle position. Throttle voltage. And we see without the computer running, reads 0.71. And then when it runs, goes to 0.69. And then IAC position. IAC desire. And then the RPMs. That's all the information. That makes it very easy for you guys to see from the distance. I am 54 years old, and I appreciate when somebody does it, so I don't have to go right next to the TV to see it. All right, so but everything is good. So let's run it, which should be an idle, and we're matching the same things: 0.69, 0.4. The IA position again, the adjusted start, and 63, which exactly matches the other module when we did this. 0.25. You see the clock is doing exactly the same thing. It's like the correct thing, sorry. And we have 0.3, 0.4 minutes, and the clock hasn't changed because it's not even 1 minute yet. So this is so far running and looking good as well. Let's raise the RPM first. Let me go up to 4,000. Hopefully we can get these two computers solved for him because I know he's going to be very happy. Trying to get this to close to around there. Let me go now to 39.5. Very hard to put it exactly. This knob is just so small that sometimes it's, I think I got it right there. Okay, perfect. So 1.84, 39.1.5, that is okay. We got 112 on this one. The other one was reading, I think I have those values in here. The IAC was 132. So we have a little bit of slightly difference from this computer to the other one as far as the eye position. Not sure why, because they're the same calibration, but the internals on the computers are not. So that I consider okay, because look at the desire and the eye position are matching. So in this case, I am still consider this normal. We are reading 652.53 hours with 2 minutes of running time. So that is good. It's looking good. All right, guys, let me run this. So we're going to wait for the 30 something minutes. So I'll be right back. I have lunch, so I'm going to eat lunch and try to do some emails in the meantime, and we come back in 30 minutes. All right, I'll be right back, guys. All right, guys, it's been 32 minutes since we're running module number 1. Everything's looking so far good. I haven't changed the values or anything, so we will see that. This is, as you can see, is still everything connected the same way. And let's move over to here. So this is being a long video, but I think that it has a lot of good information for diagnostics purposes, how to determine what route you need to go. Because otherwise, this will be changing parts, and changing parts is very expensive for a boat owner, right? All right, so let's do this. So let's go over to the maximum again, throttle position wise. See if we still have that 99% with the same voltage. And we do. Look at that, 3.65, 99.6. So this is looking really good, guys. All right, so let me bring it down to 40% or so, just to bring the idle down from RPMs wise. So we're going to go to 650. Trying to get to around there. All right, let's bring the throttle position down to the 0.69 to see what percentage we're going to get there. And look at that, guys. Isn't this obviously beautiful? This is great. These computers both are fixed. No doubt about it. Look at the amount of time. These 2 modules we're running. I mean, this has been a long time, because obviously it's 1 hour video, but this has been like 4 hours for me invested onto these 2 computers. But we are good. Look at the eye position matching exactly as the other one at idle. We do have a little bit of a change on higher RPM from 132 to 112. Again, that's internal design. Probably the resistors are not the same values, and that can change a little bit. But again, nothing that will make any difference whatsoever for the boat running. Look at the engine hours, 653.05. The hour clock is now reading properly. It's perfect. This is exactly what we're looking for, guys. This is 100% fixed. Both computers are now working as they are supposed to. I'm so glad that I was able to fix this for these guys. This is a first-time customer, and I think I'm probably going to have a customer for life for all this help. I hope so. And hopefully he can write a good review so others can find me. Guys, thank you so much for visiting Mike Salazar Diagnostics. Thank you, Bill, for trusting Mike Salazar Diagnostics as well. I'll see you on the next one. Bye-bye.